Makoto Takemiya. I'm the co-founder and the group CEO of Soramitsu, and I'm a naturalized Japanese citizen, and I'm a computer scientist by training, and I've worked before in many different positions, mainly in research fields. My company does quite a lot of work in blockchain. So I like to describe us as a boutique fintech company specializing in blockchain technology. And we're also one of the main or heavy contributors to Hyperledger Iroha, which is one of the open source blockchain platforms in the Hyperledger project. We, of course, don't only use Hyperledger projects, but we also do other work with Ethereum. We work with Web3 Foundation on Polkadot, also with Filecoin. So we do quite a lot of other work, but we try to choose the best tool for the right job. Today, I'll be mainly talking about our work with Hyperledger Iroha, and we've done work, a lot of different work over the years. Our company's almost 5 years old, but I'll spend, I think, most of today talking about the work with the Central Bank of Cambodia, because that's an interesting example. But we've done other work as well, including working with the Central Security Depositories of Russia and Slovenia, and working with Bank Central Asia and Indonesia on a digital identity prototype as well. So yeah, I'll talk mainly about our work with the Central Bank of Cambodia, which is on Project Bakong, which is a digital real-time payments project. In recent years, I think everyone knows that central bank digital currencies have been a popular topic, and it becomes increasingly popular by the day, it seems, as central banks are starting to think about how do we digitize our liabilities and create more efficient backbone systems so that other regulated entities in the country can use for new types of services and payments infrastructures. And of course, everyone knows the work being done in China. Other countries like Sweden and Turkey have talked about things. Ukraine has done some experiments. Banque de France has been doing some experiments. That even India has been talking about needing a sovereign digital currency. So there's quite a lot of work being done. But our work in Cambodia is actually, I think, on the large scale, it's one of the first. There's, of course, been smaller work being done in the Caribbean, for instance, and other places. But as far as launching with real money and making it available to an entire population of a non-trivial size, Project Bakong was the first. And I'll talk a little bit about the history of the project, but a general overview is that it's a payment system that allows anyone to send money to a phone number, a Cambodian phone number. So if you have a Cambodian phone number, you can send and receive this digital currency. There's white paper, of course. You can search for it online. NBC has it on their website. We also have a pretty good informative website about the project at Soramitsu's homepage as well, soramitsu.co.jp. So you can find some of these resources there. Yeah, I think an easy way to kind of start is by showing the app itself, and then kind of taking a step back and explaining, how it was built and what the story is. So this is the app, and I'll show a demo because I think it makes sense to kind of show, trying to and let's see here. So this is the app here. So this is a simple wallet application. Here, I'll make this full screen to be less distracting. In Cambodia, they support multiple currencies because it's a very heavily dollarized economy right now. So it has the Khmer Real, which is the domestic currency, and the US dollar. Like many payment systems in Asia, it uses the QR code-based system. So you have, like, you can send and receive money using a simple QR code. You can also, if you have a bank account at one of the partner institutions, you can deposit money directly to one of these if you happen to know what a bank account number is. But the main use is for people who maybe are underbanked or unbanked in Cambodia, and so the biggest use is really to send money to a phone number. So you can choose a phone number and maybe send, for example, 1 real. Maybe you can say like some message like hello, hit send, and then you hit confirm, and it actually sends. It signs the transaction on the device and sends it to the backend system, which is using the Hyperledger Iroha blockchain. And then you can see it's already done, and it says success here. So people, when they think of blockchain technology, they usually have this image of it being slow or non-performant, mainly because Bitcoin takes like 10 minutes or more to make a transaction. But really in the private enterprise setting, you don't really have that problem. Like the technology is really fast, and it gets faster all the time. So so anyway, that's a very quick introduction to the user interface and the app. I'm not going to go into all the details today, but I will talk a little bit about the story and how this was made. So really, the story of Bakong starts in 2016 when the National Bank of Cambodia started on the project. So back then, of course, blockchain technology was a little bit. Can you hear me? I'm not sure if the internet is breaking up or not. Having some connection issues. 1 second.
Yes, we can hear you, Takemiya. Go ahead.
Okay.
Yeah.
Okay, great. Yeah. Yeah, I don't know why, but my computer's having some issues. I'm going to turn off my video just for now, and maybe turn it on later during Q&A. So the story of Bakong starts really back in 2016 when the central bank started to look at using blockchain technology for a new type of payments system. Like, for example, just like they wanted to increase financial inclusion in the country, and so they figured that blockchain would be a good potential candidate for the technology, because blockchain technology allows really decentralized application development. So what I mean is that every device in the country can have their own keys, and the central bank doesn't have to control the system, who's in the system, what the identities are. Instead, you can just have private keys on everybody's phone, and then these individuals are intermediated by the banks. So they started studying this type of technology back in 2016, and then in 2017 we joined with them to build the system. And in 2019 we launched a pilot that actually used real money, and anyone in the country could start to use. And then officially this year in October 28th, we did a full launch of the system. And this system's gotten a lot of press and people interested in it, including we worked with we went down to Cambodia actually in before COVID in January with Yamamoto-san, who's one of the members of the Japanese Parliament, and he even met with the Prime Minister to talk about the system and many other things as well. And then, like I said, the system launched officially in October 28th of this year. Unfortunately, I wasn't able to be in Cambodia at the time because of the pandemic, but it's really encouraging to see the support that the country has given. I'll just talk, I think, a little bit about the architecture, and then if there's any other questions about the system, I can talk maybe more in the Q&A about it. So the architecture, like I mentioned before, uses Hyperledger Iroha, and it's a 2-tier architecture. So the central bank runs the core system in the backend, and let's see. Sorry for being slow. I think my screen sharing kind of dropped off for whatever reason. So you should be able to see the screen now. There we go. Great. So yeah, if there's any problems with the connection or hearing me, just let me know. But I'll assume there's no problem. So like I said, the system is a two-tier architecture with the Hyperledger Iroha blockchain at the core. And this is run by the central bank. So the central bank actually runs the ledger itself. And then all the participants, all the end users connect through commercial banks. So you don't disintermediate or remove the commercial banks from the system. Instead, you give them a new job to do. So they run payment gateways that each mobile app connects to, and they also provide customer onboarding and support, and they can build different services on top of it. Here's another view of the same architecture. So yeah, it's basically the same as the other screen, but you can see that yeah, the commercial banks are providing quite a lot of services. And then in Cambodia, actually, the integration was very easy with the blockchain system because all the banks use ISO 20022 messaging, and it was a pretty simple task to implement this and roll it out across the country. And I talked about these things. So you might be wondering, what is this? How is this different from, e-money systems or other types of systems that that exist already? The Backong system, because the ledger is being managed by the central bank, every transaction actually has settlement finality. So the transaction that I demoed earlier only took a couple of seconds, but actually that has legal finality with regards to the payment. And this doesn't matter whether you're sending inside the same bank or across banks. It's just, it's agnostic about like what bank is actually being a counterparty to the transaction. This is very different from what you have in the traditional e-money type of system, where you would typically do some kind of like a charging of the e-money. So you would like give cash to some institution, you would charge up your balance, and then you can pay by sending an instruction for payment to a store. But the store doesn't actually get the money in real time. They actually have to settle. And this settlement period is different depending on the country and the system. But in many places in the world, it's about either 2 weeks or 4 weeks. And so the store actually has to wait, quite a lot of time before receiving the money. And this is, not so convenient, of course. So in the Bakong system, once you charge up your balance by giving cash to like one of the partner banks, they give you these Bakong digital balance. Then when you make a payment, the payment is instant and it's settled in real time. There's no deferred net settlement. And so you don't have to worry about netting or anything. You just make the payment itself directly. And the store has the money instantly, and they can use it for, either making other payments or cashing out. And so it makes the payments infrastructure a lot easier in the country. So you may be thinking, like, why did we use blockchain for the system? Because you could use, in theory, just a database or other types of structures. Using blockchain, especially Hyperledger Iroha, I would say simplified the payments architecture because all the participants are at the same level. So commercial banks and users and other types of counterparties, they all are just wallet addresses on the same ledger. And it's just very simple to have this kind of flat structure to send and receive money with the different participants. And then I would say that also because the system, each end user generates their own keys on their own devices. The system is more secure than a traditional database that could potentially have, one master set of keys and account balances that could be hacked. So this is much more distributed system. So you distribute the risk and you make it more of a trust minimized system. And this also you can say that gives users a mathematically provable ownership of their assets, because you can actually prove that if you can prove that you own some assets in your account by signing a message, for instance. Um, and so some of the reasons why this system was built is because in Cambodia there's a large unbanked population. There's also large remittance markets, so there's lots of domestic and also foreign remittances that are being made. And at the same time, there's very few options for digital payments. So things like e-commerce are not developed as much as I think they should be. And part of the reason is because of a lack of digital money. So most transactions in daily life are based on cash. So with Bakong, because the efficiency increase of using a system like this over cash, you can potentially add about 1%, 1 to 2% to GDP. And in Cambodia, that's about 1 million a day. And that's quite significant, I think. And it's an easy way to help help the economy, especially in a time with the pandemic when many countries are having difficulties. The system, as you saw, is pretty fast, and at least from a human standpoint, it's faster than cash, and it makes remittances really fast and easy. It doesn't matter, where you are geographically. You can send money back home to your family, or even do things like pay bills, remotely, which is quite a useful thing. And it gives people access to digital payments. So it can help create a whole e-commerce industry that didn't really exist before. On the other hand, you might be wondering, what are the effects on monetary policy of a system like this? So the system that we worked with MBC to design was really made so that there's no effect really on monetary policy, because this is really just a digitization of physical cash. So it works just like cash, and the minting and deminting works like cash as well. So it's like 100% reserved narrow banking type of system. And the daily transactions also have a limit on how much you can send, so that there won't be competition with bank deposits. And of course, there's no interest being paid on these systems. The same system can be easily implemented in other countries as well. So this system, of course, has been audited by many external auditors, and it's been in use for a while. So for example, in India or as any other country, you could build some system like this, where you could have the central bank running a blockchain-based core system, and then you have maybe some KYC utility to make compliance easier, and then the commercial banks would provide the service to retail and wholesale customers. And many studies have shown that you can add about 1% to GDP because cash is pretty inefficient. Besides that, we've done a lot of other work, and I'll kind of go through this kind of fast, but we've done a lot of other types of systems with different payment systems. So for example, we worked with the University of Aizu in Japan on building first we did a system called Moika, which is it was just like an event-based cryptocurrency. And then we actually rolled out a system called Byakko, which actually I can show you a demo of. So I will do that. If I can get my okay, great. So so this is a Byakko system, and this is a digital currency that we made for the University of Aizu, which is in Japan. And this is also using Hyperledger Iroha blockchain, and it's really just made for people to like go to the cafeteria, and you can scan a QR code and send money. I'm gonna just send maybe 1 yen to this guy and say like hello. um, hit send, and then it's just like in a Bakong system. So it's actually processing the system now, and the transaction should show up here. See, it's processing, and it should take a couple seconds to do. Um, but this is a system that's been in that launched in July, and here you can see it's done now. This system launched in July, and like a Bakong system in Cambodia, this is a system that allows people to basically do like a prepaid system. So you hand physical cash over to a person at the university, and they charge up your balance, and then you can use this money only within the university. So like you can go to university cafeteria or to bookstore, uh, and you can also do peer-to-peer transactions with other people at the university. Like I just sent a transaction here. So this is real money, and this system has been in production now for about 5 months or so. And so this is some of the other work that we've done with payments using Hyperledger Iroha. And let's go back to my slides. So that's Byakko. We've done a lot of work. So you might be wondering, why did we use Hyperledger Iroha for these applications? Like, what makes Hyperledger Iroha useful for payments? I would say it's because in Hyperledger Iroha, we have a design philosophy that for things like simple asset or identity management, it should just be really simple to create the assets and transfer assets. You shouldn't have to write smart contracts that manage all the account balances and logic. So what we have prepared is a set of out-of-the-box instructions that make it really easy to do simple asset management. So for example, you can create an account, you can create an asset, you can transfer an asset to an account, you can manage the permissions for these different different parts of the system, and it just makes it really easy. So instead of having to write all the logic yourself, you can just create your assets and build you can focus on building applications that use these logic. So we spent a lot of time building mobile applications and different libraries. Like there's a Swift library for iOS and a library for Android that make it pretty easy to manage these instructions in your mobile apps. So we want to make it really as easy as possible to do simple payments use cases. We also have a pretty robust permission model in Iroha. So it's a role-based access control model. So you can actually, for these different commands that you can execute, you can actually set permissions on who is allowed to execute these, and you can give different people different permissions. So we use this in some of our applications. So for example, like in querying data, if you're like a bank or something, you only want to query your own users and not like all the users in the system. So that's something that can be managed at the permission level on the blockchain. So it's actually a very secure way to manage the permissions. And you can also create a segregation of powers. So instead of having like a super user administrator, you can have an administrator who has rights to access some data and execute some commands, but they can't execute other commands. So it gives a finer grain control in the setup. And I already talked about this, the privacy. So the queries also have the same permissions associated with them. And the combination of these permissions also allows you to create like nice user experience as well. So for example, people lose their phone quite a lot. And so if you lose your phone, you don't want to lose your access to your account, right? So what you can do is you can grant the permission to change your account keys, your account signatory keys to another entity like a bank or an administrator. And then if you lose your device, you can go to this person and say, hey, I need I need to replace my key or add a new key. And this bank or administrator can add your new key that you created without ever accessing your private key. They only use a public key for this. So this is really useful for applications like I showed you at the University of Aizu in Japan, where if you lose your phone, you don't want to lose your account. So you can actually, because it's a campus payment system, so everyone's identity really is known. So you can go and prove your identity, and you can change your keys associated with the account. So version 1, I will just show you quickly the GitHub because we recently so if you wanted to actually play around with the system, the best place to start is probably the GitHub page, and then you can go to the wiki by clicking on this link over here. And we also have some releases here. If you click on releases on the right-hand side, we have Iroha 1.2, which was released fairly recently, 14 days ago. And 1.2 we spent actually most of this year working on. It has some very nice improvements, some minor bug fixes, and the performance is also improved, and reliability, I would say, is also better. And we support a new type of cryptography like Hyperledger Ursa, and we also integrated with Hyperledger Burrow. So if you're interested, yeah, please, you can get the release here for 1.2 and play around with it. So if you're going to use Iroha version 1 based system, that's what I recommend. And version 1 is written in C++. So if you're familiar with C++, you can also feel free to contribute. We're also working on version 2. And Hyperledger Iroha version 2 is actually being rewritten in Rust. We started this process back in February, and we're getting close to an initial MVP. And on GitHub, the way it looks is, if you go back to our GitHub page, our branch would be, the main branch to look at would be Iroha 2 branch is kind of mostly stable, and then Iroha 2 dev is going to be a branch that we use. This should also be fairly stable, but sometimes things can break. And if you go down into docs and source, you can read a little bit about our design in the white paper. So we have this Iroha 2 white paper, and you can kind of read about things like the consensus algorithm and some of our design philosophy as well. So if you're interested in Rust, feel free to come by and contribute here. And then additionally, on the Hyperledger wiki. So if you click on the wiki here, we try to do a lot of the work that we support here on the wiki. You can go to Iroha 2, and then Iroha 2 area has all this information about architecture, and for things like the design, we always we discuss things in these requests for comments. So things like Merkle tree structure is discussed here, and everything is public, so you can read about our decisions and contribute, and it's it's an open source process. So I really encourage people to to come by, and if you want to, you can contribute. So that could be interesting maybe for you. In Iroha 2, we're kind of expanding the idea of the Iroha version 1 commands to create what we call Iroha special instructions. And this is a Turing complete, or when we're done with it, it'll be a Turing complete domain specific language that you can use for asset management and well, anything really, but our main use cases that we focus on again are things like payments and digital identity. So these are the use cases that we're looking at, and we also have been working on kind of an improved Byzantine fault tolerant consensus algorithm called Sumeragi. So this is a little bit of improvement over consensus in Iroha version 1. So it should be a little bit faster and more reliable. The basic idea really is, well, there's some time, so I can go into it, I guess. The basic idea is you have nodes on your network. Let's say there's 4 nodes, which having 4 nodes allows you to withstand one Byzantine fault. One Byzantine faulty node, and like given previous BlockHash, you create a random ordering on these nodes, and this changes every block, so it's really hard to manipulate the system. And then you choose the first node as the leader, and then you have what's called a proxy tail, which would be the like within the set of 2f+1 nodes that you need. Well, it's actually the end of the 2f+1 set. So if you want to, so what this system does that's different from other type of Byzantine fault tolerant algorithms is that it applies this ordering over the network nodes. So so when messages are sent, they're sent in a specific order, and if a node doesn't get a message, you have a rough idea who was bad, and then you can kick this person out. So you have like a set A and the set B. Set B is only used when there's a problem in consensus. The leader creates a proposal and sends it to everyone in set A. Everyone set A should then sign it and send it to the proxy tail. And then the proxy tail should broadcast a commit. And if you don't get commit somewhere, what you can do is you can actually rearrange things. So like the process kind of continues in this random order, and there's deterministic timeouts. So if a node doesn't get a commit message within the expected time, then you just you rearrange the ordering of the nodes and you try again. So the normal consensus flow for this is really highly optimized because in a permissioned blockchain platform, most of the time you're not going to have any faults. But if you do, you still have liveness guarantees and safety guarantees for consensus, which is nice to have. Well, it's required. So that's one of the things that we're doing. I'll just kind of share a couple of ideas about my long-term vision. So what we're hoping is that for Iroha version 2, that we'll launch the basic payments use case commands within Q1 of next year, and then we can integrate this into like existing payment systems that we've done, like for example, Byakko and Bakong. But we're also doing quite a lot of work on a public cryptocurrency project called Sora. And Sora is a decentralized economic system, and there's a cryptocurrency called Zor, XOR, and another one called Val. And people use this for basically incentivizing productive economic activity. And right now we use actually Iroha version 1 for a part of the network, but we built a bridge between Ethereum and Hyperledger Iroha version 1. So actually I should I'll show that to you real quick. So we have a D3. We did a lot of work with some different CSDs, like for example in Russia and Slovenia, and we built a project called D3 a couple of years back. And as part of D3, we have an Ethereum bridge that you can find on GitHub under D3 Ledger. And what this allows is it allows you to move Iroha version 1 assets from Hyperledger Iroha to Ethereum, and then you can move them back from Ethereum to Hyperledger Iroha. So it allows you to create a multi-platform asset, multi-platform token. And this has been running in production for a while. We haven't had any problems with it so far. So you can play around with the code and see see how it works. And so for version 2 of the Sora network, so we're using version 1 now, but for version 2, we're going to be using Substrate, which is a part of the Polkadot ecosystem. And we're going to become a parachain with this. But for version 3, what we're looking at is using Hyperledger Iroha version 2 to actually implement the specification needed to become a parachain of Polkadot. So being able to support, WebAssembly runtimes and different types of, messaging with the Polkadot relay chain and Kusama relay chain. So this can provide a nice alternative for people who want to just create a simple digital asset platform without having to work with lots of different frameworks. You can just work with Hyperledger Iroha version 2, and you can easily connect to many other blockchains like Ethereum or Bitcoin or Polkadot or Kusama. So that's like the end goal of what we're doing. So this is not going to happen anytime soon. But if you're interested in this type of thing, feel free to help out and join the Hyperledger Iroha development. And with that, I'm happy to take some questions. I think some people wrote some questions in the chat, so should I just go through these? So yeah, I'll just kind of go through some of the questions here that are in the chat. So one question was, will the slide deck be shared with us? I'm happy to share the deck. I don't know who to give it to, but maybe someone can contact me on Telegram, and I'm happy to share it. Okay, and then somebody else asked, this is about, I guess, the BlockHash system. How are customers connected to banks, like peers? And so the architecture is actually like I showed in this figure, where you have the mobile apps that end user has, and these are connected to a payment gateway, and then the gateway actually connects to the blockchain platform. So the actual peers on the blockchain platform are running not at the commercial banks, but at the central bank. So it's a two-tier architecture. So these are the questions that were in the Q&A. Let's see here. So any other questions that I'm happy to answer?
Any other questions, attendees? If you have any questions, please do type your questions in the question box.
So one of the questions in the chat is, how do you see money programmability being leveraged in retail CBDCs? Which is actually a great question. So especially in Hyperledger Iroha 2, we want to make it really easy to do event-based asset management. And so like you can have like some conditional event, and then if you have a conditional match, then you do some output. So you can have like a programmable money or smart money, which actually can do really interesting things, I think, from a macroeconomic perspective. But the thing is that central banks, I think, are very conservative, and so regulators are very conservative, and so um, it's really hard to explain programmable money and different use cases of this um, to central banks and other institutions. Um, I think these applications have to be built in the private sector first, maybe, for example, in the cryptocurrency space. And then once they are shown to have some value, um, they can then be used uh, in like traditional financial markets infrastructure. Um, so another question that was asked was, do we need apps to be decentralized as well? And yeah, this is a great question. So one thing that a lot of people um, maybe don't realize when they first get into blockchain is that uh, there's actually quite a lot of centralized infrastructure in a lot of these systems. So if you have a mobile app, typically you don't connect directly to the blockchain system. You have some middleware. Um, and even things like push notifications are typically run in a centralized server that you register with. So, um, so do we need apps to be decentralized? It's a desired thing. I think it's much more efficient if you don't have to have middleware. If you can just have apps connecting directly to the blockchains without having to go through other intermediaries. Um, so uh, this is kind of the area, the way that the technology is moving. It takes some time to get there, but we're trying to build tools, for instance, that allow our payment apps to connect directly to the backend system without having to go through like a gateway or payment um, middleware in the future. Another question is, any challenges when you do something new? So um, I think the technology is not really the hard part. The technology gets better all the time. It improves every few months. I would say that the hardest part would be maybe being able to explain the potential of the technology to different stakeholders and getting people to build applications that can actually take advantage of what the capabilities are. Because a lot of people don't really understand everything um, about it. Another great question is that how would we, you know, well, there's a couple questions that I think are related. One is they want to deploy the backlog system in another country, like Panama, or but really any country could be the same. Yeah, it's possible, I think, to license this technology. Well, I mean, I don't think I'm just being Japanese and not answering directly. So, yeah, it's possible to license the technology. We just have to have like a clear, business case, business relationship, and figure out, what the model would be. Um, and then this kind of goes along with: is it possible to add fee collection to or transaction fees to a system like this? And the answer is yeah, you can add transaction fees. It really depends on the business case, right? So technology is getting so good that transaction fees are trending towards zero, right? Right. So it's to really monetize payments infrastructure, some kind of new value add has to be created. Uh, at least that's my opinion about the future. Um, Another great question is the system being used in Japan? Yeah, Byakuo system is being used at the University of Aizu in Japan, which is in Fukushima Prefecture. So, but this is very small area, but it's a good initial start, I think. Let's see, there's other questions in the chat. A few questions here. One question is, what will be the competition from other DLTs and blockchains dedicated to payments like Corda and Ripple? Um, well, I'm not going to maybe speak so much about the competition, but yeah, there's always new systems coming out. There's always going to be competition. I don't think it's really that concerning because I think all the technology is pretty close in capabilities. It depends really on what the use case is, what the user needs. So even using this, different, even using the same DLT or same blockchain platform, the way that you design it, the variables that you choose, and different things like that can have a very big outcome on the system. So it really depends on how you design it, not really the technology, I think. Can you give us a few links for us to build a sample network in Iroha from scratch? I think our wiki has some simple things like this. I know there are some different demos and ways to easily set this up and play around with it. But unfortunately, whoever designed our documentation didn't really think about finding this in an easy way, I guess. One of them is Katakoda. We have a pretty easy way to do things. Anyway, you can go to getting started section here on we have a documentation on iroha.read the docs.io. And if you go here, it says how to create a network using Docker and setting everything up. So it's not too hard actually. Let's see. There's a couple other questions. One is from a central bank standpoint, what are the drivers for choosing Iroha over Besu? Well, I think not having to write Solidity code is a big plus. So that's something. Solidity is not always very friendly to write code in, but it's really just a design choice. And like I said, the technology is only one variable, and how you design the system and the business rules you have are much more important than the technology you choose. Someone asked, as a beginner, where can we start if we want to contribute to Iroha 2? Yeah, so if you have knowledge of Rust, I don't think we yet have. We have a Jira board set up. Let's see if I can find it easily. So we have a Jira board set up, and this is public and managed by a Hyperledger project, but it's asking me to log in, and I don't want to log in right now. But if you go to our Jira board, there's some tasks there that you can see. You can get there by going to the wiki and then click on Iroha 2. And then you can see that at the bottom it says contributions and requests, and then you can just kind of go to Jira here and find some tasks that you want to work on. We also have every 2 weeks we have a meeting with the community to discuss things, and we can make this weekly if possible or if needed. And there's also easy ways to communicate with us. Let me see if I go here. There's if you go back to the top of the wiki for Iroha, there's a chat, so you can join us either on a Hyperledger chat or Gitter or Telegram. All these are linked. We have a bridge that sends messages between the different chats, so it doesn't matter what tool you use. You can just choose one of them. So you can just jump in to one of the chats and write some messages, and we can try to give you some tasks if you want to help out. So that's all the questions that I have currently. Do you have any other questions? Oh, there's somebody wrote something in chat. Oh, okay, thank you.